Hello everyone, we are on to lesson 2, composite shapes. So in lesson 1 we did perimeter and area, and we looked at what the words meant, and we solved the perimeter of different basic shapes as well as the area of different basic shapes. And we did so using the formulas that are on the front of lesson 1. All right? And what we're doing in lesson 2 is we're going to add on to what we did in lesson 1. By that I mean that we are now going to take what's called composite shapes and find their perimeter and their area. And of course we need to first define what a composite shape is. All right, so a composite shape is a shape that doesn't look like a basic shape like we did in lesson 1. It looks irregular, a lot like what you see in front of your screen right now. That U shape isn't a basic shape that we know of, right? But it can be broken into basic shapes. So what I mean by that is if you take this U shape that you see in front of you, and I were to just draw a line going down here and a line here, you can see that I have now taken this overall shape and I have broken it down into 3 rectangles. Now this just happened to break up into rectangles, but it could be any combination of shapes. It doesn't have to just be rectangles. All right. So remember your definitions of perimeter and area. Perimeter is the boundary around a figure. Okay, so it's the boundary, the length of the boundary around a figure. And area is the space within that boundary. So it's like coloring in this shape here. That would be what's known as the area. All right, so let's just fill in this little note section here to just write down what I had just said. So a composite shape is a shape that is made up of multiple basic shapes. And by basic shapes, I mean a circle, a rectangle, triangle, etc. Okay? But then how do we find the area of these shapes or the perimeter around these composite shapes? All right, well, I want you to follow 3 steps when you're finding the area. So this is right now for the area. We'll discuss the perimeter below. So for the area, the first thing you want to do in order to find the area of these composite shapes is to split figure into basic shapes. So the basic shapes that I listed above, right? Step 2 is to find now the area of each individual basic shape. Individual shape. So we're basically breaking down this composite shape into its smaller parts, finding the areas of those smaller parts, and then guess what step 3 will be to conclude finding the area of a composite shape? It would be add all areas of basic shapes together. So that makes a lot of sense. Right, so we're going to break down our shape into smaller shapes, find the area of each of those, and then add them all together. Now, when you're finding the perimeter for composite figures, breaking up the shapes really isn't as important. If I take you to the example above here, and let me just erase this to kind of make this a little bit cleaner. If I take this example, if I'm finding the perimeter of this shape, do I really need to break this up into different shapes to find the boundary around this shape? No, I don't need to do this. I don't need to break up this shape into different rectangles if I'm finding perimeter. I don't need to do that, okay? Because I'm already given all of the side lengths around the shape. So I can just add those all up to find the perimeter. Okay? So perimeter and area a little bit different there. So here's an example, another example of a composite shape, okay, that you may find useful is if you take a triangle and you were to take a rectangle together, you were to create this composite shape here. And with this composite shape, we can find the area inside that boundary, that bounded, those lines that are around the shape, or we can just find the perimeter. Okay, so let's go ahead and do an example, and let's take a look at the way I've laid this out on your lesson sheet. It says calculate the area of the following shape. Round your answers to 1 decimal place. Okay, so we need to remember that. Round to 1 decimal place. All right. Let's look at how this is broken down and how I want your solution to look. So you can see that I have done three different tables here, or 3 different boxes that we're going to fill in. 1, 2, and 3. The reason why I have 3 here is because one of them we're going to find the area of the triangle. Then we're going to find the area of, so we're going to find this area. Then we're going to find the area of the rectangle here. And then you can see I have a total section. So we are now going to add those 2 areas together to get our total. Okay, so pretty straightforward stuff. Okay, and remember that this is only asking to find the area. We're not finding the perimeter here. The question's only asking to find the area. All right, so let's start with the triangle. I know, and you can check your formula sheet, that the area of a triangle, the formula for it is base times height divided by 2. Okay, base times height. So go ahead and fill in those values for B and H. So we've got for B, what's my B? What's the base of my triangle? 10. Times, what is my height of the triangle? What is the height of it? H represents height. It's this right here, right? There's your height, 12.5. And don't forget to divide by 2. Do a little arrow going up to the top. And to 1 decimal place, you would do 10 times 125 divided by 2. And you would get 62.5. And don't forget your units. Meters, that's right, meters squared because it's area. So there's your final answer there. Okay, and I can just get rid of these numbers here. We don't need them. They're just making it look a little sloppy. Next is the area of my rectangle. And I know that the formula for the area of a rectangle is just length times width. All right, and you can check your formula sheet for that. So I just need to do length of 12.5. And it doesn't matter what order you put these numbers in because we're multiplying them. So that doesn't matter. 12.5 times 13.4, these values right there. Okay, and you should get 167.5 meters squared. Now, of course, you need to find the total area. So let's add them together. So I'm going to take the area of, and I'm going to use a subscript T, so area of my triangle plus area of my subscript R, so area of my rectangle, which is 62.5 plus 167.5. Notice how I don't put my units in the formula. I only show my units at the very end. Okay? And my final answer then is 230 meters squared. You can put a box around your final answer so it stands out. Don't forget the meters squared. Okay? So that example is pretty straightforward. We just found the area of a composite shape. This one gets a little bit more challenging Now we need to calculate the area of only the shaded region. Okay, so only the shaded region. Round your answer to the nearest tenth of a centimeter. The nearest tenth just means 1 decimal place. Okay, so going back to elementary school, rounding to the nearest tenth of anything is just 1 decimal place. Okay, so we got to find the area of the shaded region. Here, 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 and so on. Do you have any ideas how we are going to do this? Well, we appear to have 2 holes there through a rectangle. Okay, so it's like 2 holes were subtracted. They're taken away from the rectangle. So if we find the area of the rectangle, A subscript R, and we subtract the area of A subscript C for circle, minus, because there's 2 of them, another area of the circle, we should be able to find our total area. Okay? We should be able to do that. So let's go ahead and do that. Let's see here. Let's start with our area of the rectangle. It's very straightforward. What's our length? Well, first I guess I should write out the formula. So area of a rectangle is length times width, where in my case of this rectangle, my L is 21 and my width is 10.5. It doesn't matter what order those are in, okay, because we're just multiplying them, so it doesn't make a difference. Plug in your numbers, and you get 220.5 centimeters, that's right, centimeters squared. Now let's find the area of one circle, but then we're just going to double it to get the area of both circles because they're identical circles. So let's find the area of one of the circles. Well, let's go back to my image. Actually, it may help if we write out the formula first so we can see what we need to find. Area of a circle is pi times r radius squared. Well, looking up in my diagram, do I know the radius of my circles? I do. All right. Well, if from here to here is 10.5, that means the diameter of this circle is 10.5. Now I know that the radius should be 10.5 divided by 2. It's half the size of the diameter. So my radius is 5.25 centimeters. Okay, no squared because we didn't find area. We're just listing out what the radius is. So let's go ahead and do 3.14 times 5.25 and then square it. Now don't forget to follow BEDMAS rules. Do your exponents before multiplying this here. You've got to do your exponents first. So we get 3.14 times, what's 5.25 squared, or 5.25 times 5.25? It's 27.56. Final answer. This is where you do to 1 decimal place. Notice how in my formula I'm getting 2 decimal places. Keep them at 2 so that your answer is more accurate. And then in your last line, your final answer, just round it to 1 decimal place. You will get a more accurate answer if you do what I'm saying here. Okay? Now, that's of 1 circle, right? That's the area of 1 circle. Now, remember that our formula for the shaded area is right here. It's the area of the rectangle minus the area of a circle minus another area of a circle. And now that we know what those areas are, we can just plug them in. 220.5 minus 86.5 minus 86.5. Now we round to a tenth, right? 1 decimal place. 47.4 centimeters squared. Okay, hopefully we're getting the hang of it. One more question, just so that you've seen enough different composite shapes. This one is by far the most complicated, especially because it's asking for us to do kind of beyond what I've done so far, where we have to figure out how much paint we need to buy, what our total price will be after tax. So this is a great question. Put a star beside this question. I'm sure you'll see something like this on your final assignment. Okay. The front of your garage needs painting. The total area needs to be painted except for the door. The door is 1.5 meters high and 2 meters wide. So somewhere here there's a door. It's not drawn here. Okay, so this here would just be like your garage. We need to figure out, oh, my bad, I'm sorry. This is our door, in fact. Okay, this is our door. And so this door, they've given us the dimensions of. It is 2 meters wide, and it is 1.5 meters high. So they have given us those dimensions. So we're going to subtract, because that would be a hole, right? Like if it's a door or it's a garage, it would be something that we won't need to be painting. Or potentially we are, but we would just be painting it a different color maybe. But we most likely wouldn't be painting that. Okay, so we need to cut that out. We need to subtract that door area from the rest of the house. Now notice I said that we need to find area. We're painting this. Why does painting something have to do with area? Right? Well, we're not dealing with fencing or edging around a shape. We're dealing, when you're painting, you're painting within a shape, right? And so we're dealing with the area inside that shape. So therefore it's area that we need to find. So first question says, how many square meters of paint are required? So essentially what this is saying is, what is the area in square feet? That's what this is saying. What is the area in square feet? Okay, so let's go ahead and start to plan this out. How many shapes do I have? I need to find the area here. I know I can split this up into a triangle. That's one shape. I can take this to be, actually, let's call my big rectangle. So this is your big rectangle around there. Let's call that shape 1, just because that's our biggest one, but it doesn't matter. We'll call our triangle shape 2. And then lastly, this door here, this garage door, let's call that, or if it's just a regular door, let's call that shape 3. So remember, you need to split up your shape into basic shapes. Then find the area of each shape and then add or subtract them together, depending on whether there's holes or there's not holes. Okay, so let's do this fairly quickly. So my area of the rectangle is length times width. So this is number 1. What is my length here? It is 3.5, which is right there, times my width there is 2.5. It doesn't matter what order you put those in again, right? Okay, and so you end up getting, and let me just scroll up a little, 8.75 meters squared. And again, I'm carrying 2 decimal places because I know in the end I'm going to round to 1 decimal place. How do I know it's 1 decimal place? Because in the question here, they only give me 1 decimal place values for the dimensions. Okay? Area of my triangle. It's base times height divided by 2. What's the length of my base? Here it is right here. That's the length of my base of the triangle, 3.5. What's my height? That's my height right there, 1.2. So we have 3.5 times 1.2. Okay, and your final answer there, make sure you divide by 2. I apologize, I forgot to put that there. Very simple to make that mistake. You should get 2.1 meters squared. Now let's find the area of the door, because we have to subtract the area of the door, right? So the area of the door was what? 2 meters by 1.5 meters, and it's a rectangle. So it's length times width, and it's 2 times 1.5, which is, of course, 3 meters squared. Okay, so now the area that needs to be painted, we're just going to add the 2 shapes up, the large rectangle and the triangle, and then subtract the door. So we're going to go area of my rectangle, add it to the area of the triangle, and then subtract from that my area of the door. Write it out. Final answer to 1 decimal place is 7.9, and it's meters squared because we're dealing with area. So it's meters squared. So you've got about 8 meters squared that you need to paint. Okay, about 8 meters squared. Like if you were to go to Home Depot or some sort of hardware store and order paint, I mean, you wouldn't ask for 7.9 meters squared worth of paint. You would round up and just say that you need about 8 meters squared of paint. All right. Although when you go to those stores, mostly you're dealing with feet squared instead of meters squared. Okay, but that's a conversation for a different time. Okay, on to question B. A can of paint covers 2.5 meters squared. How many cans will you need to complete the job? Okay. So we have 2.5 cans covers. How much did it say? How much does it cover? Oh, 2.5 meters squared. 1 can covers 2.5 meters squared. That's my bad. So I wrote that wrong. Okay, so 1 can equals 2.5 meters squared. Well, we need to find how many cans we need. So I'm going to line these up, and actually I'm going to do this a little bit. We're going to use what we learned in Unit 3, everyone, ratios. Okay, so I'm going to write this out a little bit different, just like we did in Unit 3 when we did ratios. So if 1 can covers 2.5 meters squared, put your equal sign. How many cans, let's call it X right now, how many cans will we need to cover 8 meters squared? So I rounded my 7.9 up to 8 meters squared. Cross multiply. Okay, so do X times 2.5, which becomes 2.5x. X times 2.5 is 2.5x. And then 1 times 8. So 8. 1 times 8 is 8. Last step, divide out the 2.5. Okay, divide out the 2.5 on both sides. So x equals 8 divided by 2.5. Final answer, okay, is approximately, okay, so it's about 3.2 cans, which means how many do you need to buy? 4 cans realistically, right? You can't ask for 0.12 or 0.2 cans when you go to the paint store. You need to just buy another can. Maybe if they offer a smaller can, you can buy one smaller can, but we need to buy 4 cans. 4 cans. Now, did you have to do all this work in order to come up with this answer? The answer is no. All right. I know that a lot of us will be able to just know that you should do 8 divided by 2.5 to figure out how many cans you need, right? But if you can envision that you need to do 8 divided by 2.5, use this bulletproof ratio method where you say that 1 can covers 2.5 meters squared and set that equal to X number of cans needs to cover 8 meters squared. Notice that I put the same units on the bottom, meters squared, and the same units on the top, cans. All right, so I have 1 can and then X amount of cans, and then I have meters squared in the denominator. Okay, so now the cost of paint. The cost of paint. Well, how much? Did they tell us how much 1 can of paint was? Let's see if in the question they told us that. They did. If 1 can of paint costs $19.89, how much money will it cost you to paint the side of your garage? So basically, how much will it cost us now to paint all of this side where our garage is found? Okay, so you are going to take $19.89. We need 4 cans. We need 4 cans, okay? And it's $19.89 per can. So we're going to take 4 and multiply it by $19.89. Okay, because we need to buy 4 cans. Each one costs $19.89. Our total price there is $79.56. Now, when we're dealing with money, everyone, you have to have 2 decimal places. That's how we deal with money in here in Canada and amongst other countries. You have 2 decimal places when you're talking about the amount of cents that are required. So in our case, we have $79.56. Last step, okay, is the cost including taxes. Well, let's see how they worded the question. Okay, so let's go back up to D. In Ontario, the tax rate is 13%. So we did this, okay, again, we did this already back when we did Unit 3. How much will your paint purchase cost including taxes? No problem. We're going to take our price of $79.56 because that's how much our total price was. And now we're going to find how much including taxes. So we're going to multiply. Okay, you multiply by 1.13. So 13%, remember, is 0.13 as a decimal. Divide by 100, you get 0.13, right? But because we want to make this bigger than 79.56, multiply it by 1.13. Always, when you calculate tax, multiply it by 1.13. Okay, so basically, we're looking to find what our total cost will be if 79.56 were just 13% bigger. Okay, if it were 13% bigger. And so what you would find once you pull your calculator and you do it, your total price will be $89.90. put a box around it, and there you have it. Okay? So, that concludes this lesson. This last question strongly suggests you're going to get a question like this on your assignment, like for sure. So I strongly suggest cover up my answers, okay? Or try this question on your own in the worksheet that is provided on my website or in your booklets, okay? This question is straight from your booklet for lesson 2. Try to do it without looking at what I did and see if you can come up with all the same answers. If you can't get it, look back and look at how I did it, watch the video again, and then just keep doing it until you can understand a question like this. This is a real life question. I mean, I can't tell you, if you're actually painting your house, you're actually making these calculations. Except the difference is you wouldn't be given these dimensions. You would have to measure these dimensions, right? Like the 1.2, the 2.5, the 3.5, and whatnot. You would actually have to measure things out. Another thing that I just did recently was place new grass in my backyard. So same thing, I had to measure out my boundaries and then break up my boundaries into smaller basic shapes, find the area of all those shapes, because when you order your grass, you have to tell them how many square feet you want. In this case, we found square meters, but like I said, most places will deal with square feet. So you have to calculate how many square feet you have, and you literally will go through this exact same exercise of taking your composite shape, breaking it up into simple basic shapes, finding the area of each basic shape, adding it together. Okay? This way, when you call up the place where they're going to put new grass in, you can say, I need 600 square feet worth of grass, and then they'll tell you how much that costs. All right, so this is really a real life application, not just for painting, but also for if you're laying stone, maybe in your driveway, if you're doing concrete on your driveway, if you're doing grass, like I said.